All right. What the hell was that? No idea, dude. Sound like a frog. Okay. This is not right. Rice Krispies are off. Okay. Sounds like off again. It's not quite. There we go. Okay, so let's go to this. Let's go to this. Let's go to this. And that should be showing up any second. I got my like invisible bottle here of invisible water. Not that invisible right now. Okay. So, the last time, oh yeah, and like, let's see how long it takes for this to crash, the friggin' Ethernet dongle. The Ethernet dongle that I need because my fiber connection is faster than the damn Ethernet jack. Anyway, last time, I guess that was Thursday or Friday or something like that. Probably, yeah, doesn't matter. I think it was Friday. I was filling out, so where was I? I was trying to deal with the fact that this is Sense Atlas, which is I am actually using to plan its own development. And I was using it to figure out, determine just what the heck to do with this caching business. So like this thing is highly self-referential at the moment because I am using Sense Atlas, which is a tool that I wrote to run on top of an application server that I also wrote, or rather I wrote in this application server called Intertwingler. And for various reasons, I need to implement internal caching. Because I was going to do it anyway. I mean, that was sort of the plan all along, but I had a very particular way that I wanted to do it. And so, oop, come on. I don't understand why that does that. Anyway, oh my God. Oh, well, there was a very particular way that I wanted to implement this caching. It was a content addressable store, la-di-da-di-da. And then the question was, well, you know, so I already know how I'm going to do the cache entity bodies. And what this is showing right now is like basically, this is like your requirements in hairball form. And of course it is slow because I am now watching it. So yeah, anyway, it'll speed up in a second, I'm sure. What in the frickin' hell? Oh, finally, God, okay. Or will it? Just see the damn load on it. Okay, that's weird. Okay. So, I mean, if I was going to go from the top, I could even do that. Because this basically tells the story. So if I go from the top, I would go here. Why are you so slow today? Swear to God. Okay, we're not gonna. Swear to God. What did I say? I said the friggin' Ethernet dongle was gonna crash. Yep, it crashed. Had to go and unplug it and plug it back in. Now, where the hell was I? Oops, no, there. So, maybe this will be faster now. Oh, that's something. Okay. So, the problem was that Google, in their infinite wisdom, is nuking XSLT, and this is all, not all of it, this is JavaScript, but the template stuff is being transformed by XSLT, and it does that because, in my opinion, XSLT actually got it right. It got it right 25 freaking years ago. And this basically was like the same worked great for 25 years, and then they were like, because there was a vol in the implementation in Chrome. So, Google has in fact, so like what you're looking at, so let's do that. What you're looking at is, this is like a graph of issues, positions, and arguments. So this is kind of like, imagine tweeting your software requirements. That's what this is. Well, that shat the bed again. That's not the right freaking one. So this I don't understand. Trying to create the stream title. Create. Did that do it? I don't even know yet. Okay, so where were we with the damn dongle shitting the bed again? No, God fucking damn it. Don't you love it when stuff goes full screen and you're like, I did not ask for that. Anyway, where are we? This. So the thing in the middle is the same as this. It's got neighbors. So, where the hell was I? Basically, like, he just wipes my brain every freaking time. And of course, I have to, like, be watching it, because in case it freaking craps out again. And it was, like, fine. It's been fine for days. The second I start streaming, it freaking craps out. Okay. Where was I? Oh, and the other time too, it was like not just, it was Nginx that crapped out as well. So it wasn't just the dongle, it was also the relay. Anyway. So we got a problem. The problem is Google's going to get rid of XSLT. So any day now, they're going to push an update to Chrome, and every single thing of mine that I've made on the internet is going to not work for 80% of people who use a web browser, because they're like 80% of them are based on Chrome. So I have to do something about that. And the thing that I have to do is create a server-side XSLT transform. So the pink guy here you were looking at was an issue. You're real slow today. Why are you so slow? I'm like watching the debug output in the other window. Okay. Normally, like, I'm like working on this all day long and it's like blip, blip, blip. Now it's just like chug, chug, chug. So I don't know what the hell is wrong with that. It's like, oh, why don't I show this off? Like, oh yeah, like why don't we make you look like an idiot? Great. Okay, so anyway. So create an XSLT transfer, client-side XSLT, or server-side, yes, fine. That's nominally easy enough, but the problem is we were relying on browser cache. Apparently that's not freaking working right now to keep the XSLT from being intolerably slow. Now, the answer to this is to implement internal caching. And so that's what we're talking about today, is internal caching. Now, there's some concerns. There's some issues that are raised by this matter of internal caching. And the one that I am interested in today is how the heck are we going to represent metadata for the cache entries. So the other day, I was working this out and I determined that I was going to write an ontology, so like a data vocabulary for this. And, you know, I have some ideas around how it's going to work. I'm going to use these vocabs and what have you. So if I go over here, this is what I've got drafted so far. And it's not, there's really nothing to it. It is a subclass of the provenance ontology, and then it just uses the HTTP message ontology because those have already been made. It's like, the really nice thing about RDF is you can just pull stuff down. Like, it's basically like there's an NPM for data. And for data specs, schemas, whatever you want to call it. And you can just use them. You don't have to invent your own. You don't have to come up with your own stuff. And so that's what I am working on right now. And of course, what I've got to do is, I'll make that bigger. I'll make this guy bigger too. This is just the example that I'm working on right now. And I've already changed a bunch of stuff. So I'm going to go and I'm going to change what? Oh yeah, so I've decided to change the thing to just cache. I think that's, I had it as CM for cache metadata, but it's like, I'll just call it cache. I don't normally like having prefixes that are like that long, but whatever. It's fine. But this here is a this is going to be like an entity. This is like what a cache entry is going to look like. And as you can see, there is this SHA-256 identifier here. And that is really the sort of the workhorse. So I have a content addressable store. So the idea is like you got this thing, and it's like a cache entry has to, let's like see if I talked about it at all. So there's like a few things. You've got a, like they're going to vary by like a few potential dimensions. Like it's not like you can guarantee the actual data coming out of it like verbatim. So you've got like the, where do I get back here? So it's got to have like if it's private, and this is actually, I haven't decided if that's going to live there yet. But say you've got accept and accept language. So like those are the two dimensions that it varies on, and then you might have like another. So like there's 4 dimensions along which an HTTP resource can vary, like as far as content negotiation is concerned. 2 of them are boring, 2 of them are interesting. One of the 2 boring ones are content encoding, which means compression, and character set, which of course, if it's not text, it doesn't have one. And then the 2 that are interesting are content type, so HTML, XML, JSON, whatever, and language, and like as in natural language. And then so the question there is going to be like, how does just how does this get represented? Because like actually here, I'll just go to this. All right. Did I? There we go. So basically request comes in. To see if I'm going to be focused. Let's just make sure that it focuses. This thing loves to spaz out. Yeah, okay, so request comes in. Whatever. We got like, user request hits the URL resolver. URL gets translated. There's a couple other headers in there, so this would like accept language, accept charset, whatever, and then it's going to go to basically the dispatcher is going to dispatcher, and that's going to go to a handler. Handler, picks a handler, produces a entity body, and that's going to come back. So in here is where the cache is going to have to happen. If I was going to show a picture of Inner Twingler, let me pick that up here. I think I have one going, or no, I don't. Let's just do this, right? So this is what intertwingler looks like from the side. You got the user. The user makes a request. The request comes in. URL preprocessed resolves it to an actual stable URI. The actual request can get transformed. So like you can change the request method, or you can rewrite the URI again if you really wanted to, or you could change the headers, or you could change the body. You can just like muck with the request here. That goes to the dispatcher. Leave that alone. Then the dispatcher like picks a handler, and the handlers are like whatever specific thing. You got the actual storage here. So a graph database and a content addressable store. And so it's like in here somewhere that the cache has to live. But then you've got dimensions like, well, I mean there's the language, the compression, and the content type, and then the actual character set is part of the content type. It's like, content type, whatever / whatever, semicolon, char set equals, etc. So you got that. And then you've got, so those are sort of like 3.5 dimensions or whatever. So effectively, I'm trying to make a record format for the metadata right now that will show up in, or that will basically, you can pull it out of the graph database. And so that is the thing that I am working on like right now. And that's what this is. This is the stanza. This is the instance of the thing. And so this data will be able to positively match the actual like cache entry that's going to be in the actual what's it called? Okay, yeah. The actual cache entry is going to be like, so this is the entry in the content addressable store, and it can resolve that URL. Oops, this rather. And so what I was trying to determine earlier, in not here but here, is so like, well, yeah, how are we going to do the metadata? So can the resource identified by the hash URI be the cache entry? That was the thing that I was trying to determine just earlier. And I think what I effectively determined was it can't. And the reason for that is like, if you say, let's just go back to here. So like you get a request, la-di-da, comes in. You don't know if like, say you've got 2 authenticated requests, right? And then maybe one that's not authenticated. And you make a request and it comes all the way in here and it like picks a thing, and that produces basically a file. And this comes back. And that file is going to have like, a SHA hash, a particular hash. Where are we here? This. And so you don't know, basically, like you have no idea like if that is confidential information or not, for example. I mean, it could tell you, but like it could also, you could basically just have whatever's in here, whatever handler is in here produce, a sequence of bytes that has this particular, cryptographic hash on it. So the question was like, can this thing be here? And the answer is no, it can't, because because you could have like, it could be, because like, you know, if you retrieve an object, you make a request and you get a response and you log the time that you got it, and it's got an expiry date and it's associated with a particular entity, and it might have been associated with this or that request header or whatever. You could potentially have like two pointing to the same one. And then it's like, well, which one is it? Is it public? Is it private? Is it for this person? Is it for that person? And you can say, well, it doesn't matter, except that it might. Like, or like if it's associated. So the other thing too is also like you've got this cache origin here. So like this is like where it got it from. This is where it got the target from. And then you could say, well, it's generated at this. So this is when it was retrieved, or when the cache entry was generated. So it was like at this time we got this, and then it's like this is when it expires, like relative, like when it was generated or whatever. This I'm not like too sure about, because like this would be flattening some of the semantics in the actual HTTP cache spec, where you have like a hard expires, but you could also have a max age, and it's like you could say like how old the thing is already, and irrespective of when you got it, kind of a thing, which is its own thing. So you might actually like have a, you know, DCT modified in here, let's say, and then like I'll just take this time, and that's actually probably, yeah. That's actually probably more likely that you're going to get, because if you get a last modified on the response, like you're going to actually want that. Because otherwise it's going to be, and there's like actually like RFC 9111 or whatever, like has specifications for like it knows, or it's like, this is how you calculate the delta or whatever. This is how you calculate like whether or not the cache is fresh, which is going to be the other thing. And so I just want to make sure that the only ones that we care about are the ones with the cache, what's it called? These prefixes, cache prefixes, because those are going to be the ones in the vocab, and the other ones are basically just pulled in from other vocabularies. And so this is what RDF, this is what turtle looks like. And anyway, what else? What the heck else? So I don't know. I mean, I think like this is like reasonably good for what's it called? A demo. So I'm just going to do this, and then I'm going to play string boop with and we might as well, well, no, let's just do that. I think that's probably fine. Let's just see how it looks in the actual, this guy. Okay. I can live with that. Is this? It is not. Okay, so now what? So that's the example. I need to fill all of these elements out now. So what have I got? I have entity expires header, method, origin, principal. I don't know about this private thing because if there's a principal, that implies it's private. Like, because if you got the response and there was no principal, but you managed to match the cache on the headers, that would be presumably okay. Headers in the method. Okay, anyway, let's write these out now. Do that so that my head's not in the way. Did I call that origin? I called it a resource. I'm gonna change that. Resource. Just FYI, I'm not monitoring chats on everything. Actually, I'm having trouble with the stream place. Like, go to chat does not, you can't like right click that into a new window, and then the back button does not work. So that's a thing. So I can't see the chat and the monitor at the same time. But otherwise, I'm kind of liking it. Okay, anyway, so what did I say? I said origin. What else? Oh, I've got it right there. What am I doing? Ding dong. Okay, origin. Entity. This relates. This denotes the entity. Oops. The actual entity, actual literal representation of the cache entry. And same thing. Expires, cache expires. Cache expires is going to be a data type property. Don't know. I'll just put them in alphabetical order for now. Data type property. Oops. Entity expire. When the cache entry expires. The date time. Date time. And the cache expires. Oops, not you. Domain range. This is going to be, oh. Oh. No, no, no. This is going to be, RDFS resource. This is a resource. And then this is just grab it from you because I know you're there. It's annoying in some vocabularies where the documentation is not the same as the spec, the actual spec. Whereas very scrupulous to do that. Oh, no. This is what happens when you're not paying attention. Okay. So RDFS resource, and then, but this is expires, but this is not RDF schema, this is XSL, XSD schema. Fine. Let's just like nick it from one that already exists. Here we go. So it grabs that. Grabs this. It's annoying. Date, time. Did I do it again? Oh my god. It's getting late, but date, time, and then you are XSD, date, time, correct. And then when you look at it, and you refresh it. Yes, okay. I mean, we knew that. We just wanted to push it. Okay, so we got expires. Let's go back to this. No. Example.ttl. Now, what else? Okay, expires cache header. Nerp. Header. Cache header. Header. Denotes an individual HTTP header. Domain, cache entry, range. It says range, HT. What did I say? Message header? Probably a request header, actually. I'm not gonna declare that it needs to be that though. This, on the other hand, we have to go and pull it. Here, and then we go to here. Did I do it again? No, I did not. HT message header. No. No. Okay. Learn to type, you idiot. Huh. I just like had a thought that like if you have like a single app proto, like if you like, because like moderation on app proto happens in the app view. So if you block somebody on Blue Sky, they would still be able to interact with you on Streamplace, I'm assuming, unless it subscribed to the same moderation queue or something like that. I don't know. It was just a thought in my head, in my brain hole. Cash expires. Let me just go back here and just punt that. Let's see. I'm just gonna like dump all these in, and then that's weird. That should have a fave icon. Anyway, I wonder why it doesn't. So, message header origin principal. We got principal in here. Origin principal. Do we want a private? I'm just gonna nuke that out. I don't know. Do I want it? Again, because like if there's a principal, the implication is that it's private. Sure, why not? It's not going to hurt anything. Because that was like the only reason why I thought about it was when I was actually thinking about this being able to be the subject. But then it's like if it's the subject, then you get the potential for collisions, and it's like, well, when did you get like weird cache artifacts? So just want to leave it out. But the idea would be that like a request would come in, and I guess I should point this way because this is facing left to right. Anyway. So the request would come in, and then it would hit the cache. It would be like, do you have a match of my, given these headers? And then it'll be like, do I have a match? I don't know. And it'll look, and it'll see if there's a match, and if there's a match, and the match is fresh, then it just serves that back. And if there is not, then it passes it down the line, just like you would expect the cache to do. And yeah, so when you get the response, so when the cache engine gets the response, that's when it's going to write this thing. And so gonna have to know. Well, I mean, it'll look at the very header, and that's what it'll use to put these headers in here. And I should have something that normalizes that normalizes the request headers as well, like something in there. Because the problem is going to be, if you don't normalize the headers, then you don't like normalizing them too is also like, okay, so like if there's no like q equals 1.0, you can assume it's a q equals 1.0. But if this is in front of that one, then like it's actually kind of like saying, well, this is q equals 1.0 and this is q equals 0.999 or something like that. Which would, I mean, yeah, that would be the way to do that. But I mean, that's how I've done content negotiation before. I'm just trying to think like, because like like how is it going to pick up, basically? Like how is it going to pick up the match, unless this was the caches were indexed somehow, and that's just a freaking goddamn pain in the ass. Unless you did something like method origin, like you just did this. Actually, you would do these. And that would get you basically that, like, this would be easy to match. This would be a pain in the ass to match. Obviously, the timestamps or whatever, like, are they going to be their own thing? Like, is it fresh? Well, it's not fresh. You just throw it out. But then because I mean, I guess what I could do. Yeah, I feel like what I should do is I should just normalize the headers as they go into the cache, because like otherwise, like you're not going to be able to match. And that's the other thing too, because if there's a fail on the cache match, then it falls back to origin, and that's the thing that we're trying to make cheaper. Because it doesn't need like I mean shit like. Oops. This. Like, the reason why this is chugging is because it's generating crap every single request, and it's also round tripping like a whole schwack of stuff. And it's like, it's doing that precisely because I haven't figured this shit out yet. So, I just haven't determined it yet. I don't even know if I need, because like downstream, like this guy will have like the format and the M time and all that crap attached to it. So, like it's not even necessary. Like it doesn't necessarily even need, I mean, it needs the expires. It's gonna need, the modified and the generated at time. It's gonna need those. But yeah, it is. But like, I think that I don't know if I want the private. I think we'll just get rid of that. I don't think we need that. Okay, again, because if there's a principle, the implication is that it's private, unless, of course, unless, of course, there's a mess in there somehow, which I don't know. I can't think of it right now. I can't tell. But other than that, I think that this is going to be done-ish. Oh no, wait! I got to do the dot. Let's finish that. Okay, so let's just double check here. So entity expires header, method origin principle. Oh, there's no method. Well, what am I doing? Method denotes the HTTP method of the associated request. HT message header. No, that is HT method name, I believe. Yeah. Method class. HT method. There you go. How much you want to bet this is method class? Oh, and this needs to be method. What did I say? Something.ttl. Cache metadata.ttl. So there is the result. Oh, there's no HT. Okay, we gotta fix that. Why is there no HT? Jesus Christ, man. What's wrong with you? Am I smoking rocks? What the frick? Oh, I'm an idiot. Like, why is this wrong? Okay. See, this is why we look at this, because this had angle brackets around it, which suggested that it was goofed. So we run it now. Let's check out cache entity, metadata vocabulary. Oh yeah, let's do the properties thing, and let's just actually just, it's not CM anymore, so let's just classes dot, and CM with cache, and then replace string CM cache, boop. And we need an HT method in here. I'll make it bigger for you. What else? Expires. Oh. We also want, where's it? A second here. Transformation. Transfer. Classes dot. I'm gonna nick some of these. Here we go. Third party data types, that's what I want. Let's grab you, why not? Get out of here. Hey. Do we do XSD string, XSD token? No, we've got datetime. I think that's it. Anything else? I don't know if I need those. Well, whatever. We can just bring them back. We need them. Hey. Cache method. Where are we here? Entity expires. Oh, yeah, cache entity is the resource. Cache entity. That we put it in here. Well, that lasted a while before it crapped out again. I know you're working. Twitch. Twitch is the GIMP one now. Swear to God. I hate that thing. I hate that thing so freaking much. I don't know why it only screws up when I am streaming. The one time I need it to not screw up is the time that it screws up freaking 14 times. Okay. Although I had a decent run for a bit, I don't know. So where the hell was I? Entity origin expires. The heck? Cache entity. Tree origin expires. Entry to XSD. Date time. Equals cache expires. All right. Okay, YouTube, you're freaking. And let's just sort these. And then I gotta do the properties. But you know what? Like, I don't even know how many properties. Well, I mean, I just said that there. Sure. Entity expires. So there's 5. There's 6. 1 is on 2. And then so, how do we look? Very simple graph. When you look at some of the other stuff that I've made, like this guy, for example, where is it? I'm gonna freaking go crazy. I'm gonna go mental. That thing shits the bed every 5 seconds at this point. Now, where was I? Oh, did I even not have? There. Yeah, very simple. Contrast this thing. I might just, I mean, yeah. Oh, shoot. Yeah. I'm going to call it actually because it's like almost midnight. But this is basically done. I'm just going to do the what's it called? Going to finish the property version of this, which is going to be a little bit dodgier to look at, but anyway, I don't think anybody's watching anymore, so I'm going to sign it off before this thing craps out again. So I'll just do this, my /obs stop